All right, so what is domain? Okay. Domain is your input. Okay, and it's always your X values. So just what is domain? That's what it is. Range. You guessed it, it's your output or your Y values. So how do I keep this straight? X and Y, think about that alphabetically. X comes before Y. Think about domain and range. D comes before R. So the first letters of the set match up. Okay? All right, so what are the domain and range of the function? And we're going to write it in two different notations. So we'll talk about those notations in a minute. But first, anytime I see domain and range, to make my life easier, I am going to graph it. Okay? You should have some sort of app downloaded to graph. If you're on a Chromebook, you already have a graphing calculator on there, school issued. If you have your own Chromebook, get in touch with me and we might be able to get it on yours. There's also the app Calculate 84 or Desmos. Okay, I like Desmos, so I do y equals, there's my absolute value, x minus 4. Close it out. That's what it looks like. So notice it starts right here at 4 on the x-axis and goes on. If you're doing this on a graphing calculator, you might need to know where the absolute value button is. So I'll help you out. When you go to y equals, if you go to alpha y equals, whoops, sorry, alpha window, just kidding. ABS stands for absolute value. So that's where you would find it, x minus 4. And when you hit graph, hey, that's the same picture. Okay? All right. So for notes references, I'm always going to sketch myself a little picture to remind myself what that looked like. Just good note-taking skills so that if I ever look back, I remember that that's what I was looking at. And domain is how wide is it? So where does the graph start? Remember, the arrow means it goes on forever, ever, ever, ever to the left. So it's going this way forever. Okay? We call that negative infinity. Forever and ever and ever. Well, we also notice that it's going this way forever. So that's called positive infinity. Anytime we write an infinity symbol, we close it off with a parenthesis. And this notation is known as interval notation. Okay. In set builder, for domain, we say all real numbers. Okay. Range is from bottom to top. So always do the smallest number to the largest number. So smallest number here on the y, on y, so notice that y is actually 0. So if I think about that point is 4, 0. The y value is 0. And then it goes up forever. Again, forever just is infinity in math language. I told you to always close out your infinities with parentheses. So let's make that little note. Always close infinity with parentheses. Okay? Now, notice that there's an actual point at 4, 0. Therefore, we close it off with a bracket. So bracket when there is a point there. And when I say point, I'm talking about labeling it like x, y. All right, that's interval notation. Set notation, this is where it gets fun. Notice it starts at 0 and then gets big. So we say the set, you're going to hear me say, mathematicians are lazy. We are lazy because we don't want to write full sentences. So that brace means the set y such that, remember, shorthand, such that y is greater than or equal to 0. So I'm going to write that out as a sentence. I'm not the fastest writer, so I apologize. Okay, so that is called set builder notation. I encourage you in Canvas to scroll to the bottom of today's lesson and you will see a vocab slide. If you click on that slide, any of those letters, or sorry, any of those words are attached to their definition. So just to help you out a little bit. All right, next. Let's see if we can do B real quick. So I challenge you to pause for just a second and try it on your own and then hit play and see if you got it right. All right, I'm going to go to my graph. I'm going to type this one in. For time's sake, I'm only going to type it in here. If you are using a graphing calculator, feel free. I feel like this one's pretty self-explanatory how to type it in your graph, so you shouldn't have any problems. It crosses here, 0, 0, and 3, 0. And the top, this is why I like Desmos, is I just had to touch it to see that that point is 1.5, 4.5. So I'm going to put that there just to remind myself. All right, so domain here. Again, even though it's pointing down, remember that it is going on forever and ever. Here's a hint. In this section, the domain will always be negative infinity to infinity if you're talking about interval notation. If you're talking about set notation, you're just going to say all real numbers. Okay, your domain is always your x, so sometimes our book writes it weird and uses x. Okay, range is where things can get a little different. Okay, bottom. Where's the bottom of this graph? Well, it looks to me like it's going down and down and down and down forever and ever. We call that negative infinity. Then we want to know, where's that tip-top y value? Well, the tip-top y value is 4.5. It is a point, so I close that off with the bracket. When you are practicing these problems, you will get it wrong if you do not use the correct parenthesis and bracket for interval notation. Okay, so what does that look like for set builder notation? It is the set y such that, you always start it that way. Y, notice this time it's going down. Down is little, so less than or equal to. I put equal to because there's an actual point there. 4.5. Okay, this ends this video, so you try it next on the playlist. All right, video 1 was a little bit longer than I wanted, so let's see if we can make this one super short. X and Y intercepts. I want to know what the X and Y intercepts are of this function. First thing I'm going to do is graph it. Again, I prefer Desmos, but you do you. And I still have the old function in there, but I'm going to type in a new one here. Y equals 4 minus x squared. It crosses at -2 and 2. The top is at 0, 4. So, what does that look like? Remember, I like to sketch myself a little picture here. And if you forget, always go back. 2 and -2. And it goes on forever. All right, so x-intercept is where does it cross the x? So x is this one, in case you have forgotten your Algebra 1. It happens. We have, it's been a weird year. So your x-intercepts are -2, 0 and 2, 0. Notice x before y. Never forget x before y. All right. And the y-intercepts, I'm going to change my highlighter color here. Y-intercept is on the y. Where does it cross the y-axis there? And for this example, that is at 0, 4. Super short video. Now you try it. You got this. All right, example 3, positive and negative intervals, okay? So to be positive, we're talking about when the y value is positive. Well, the y value is positive on a graph anytime it is above the y-axis. So notice this is above the y-axis. Okay, a negative interval, you guessed it, is going to be below the y-axis. Anything below the y-axis. Okay. To save us a little time, I went ahead and graphed 2x plus 10, and this is what I got. Okay, so this is the graph I got. It is linear. It is going on forever and ever. So when I think about this graph, it is positive starting right here and then going on forever. Well, that starting right here part is at -5. So it starts at -5 and goes on forever. So -5 to infinity. Okay. What about negative though? It is negative way down here, and if I'm picturing this going on forever and ever and ever, it's way out there. So we're going to call that negative infinity up until, where does it stop being negative? Where does it stop being yellow? Right there at -5. Notice we always use x values, nothing else. X values. Okay. We also always use parentheses because at that actual point, -5, 0, remember 0 is not positive, 0 is not negative, it's neither. So it's parentheses to say not included. All right, now you try an example. All right, here we go with example 4. We're getting there, you guys. All right, this one we are talking about increasing and decreasing. Again, to save some time, I went ahead and graphed both of those functions. So that first graph there is x squared minus 4x, and the second one is -2x minus 3. All right, so for increasing and decreasing, I always think about a little man going uphill for increasing and he's going downhill for decreasing. Now, when we're talking about that, we're saying from left to right, just like you read a book. You read a graph from the left to the right. So don't go backwards, left to right. Okay, so increasing and decreasing. So where on the graph is he going up? Where on the graph is he going down? So if we look at this first graph, the little man is going downhill, and then he turns around right here and starts going uphill, right? So that's what we're going to tell people. We're going to talk about, going downhill and then back uphill in math terms, okay? So we call furthest left negative infinity. And he's doing this same motion, same motion, same motion, same motion, until he is right here at 2, 4. Just like in positive and negative intervals, it's the x value we care about, not the y. So he is doing this motion. We haven't talked about whether it was increasing or decreasing yet. For that right there. This amount of time. Now, hopefully you're thinking to yourself, well, he was going downhill that whole time. So we're going to state that that is decreasing. Okay? Decreasing from that. Well, that means that we talked about he changed right there. That's where he changed to increasing. So at 2, and then forever, he's walking uphill forever and ever and ever and ever and ever. So getting exhausted there is where it is increasing. So the couple of notes, make sure that you are paying attention that it's only your x values. Only your x values. You always use parentheses. Okay. All right. Let's look at one more example. Make this one a quick one. This is a line because it is linear. And from left, so little man starts on the left. Notice he goes down forever. So he is always decreasing, no increasing. And so how do we write that? Well, we just say from negative infinity to infinity, he is decreasing. You can even, if you're trying to be above and beyond, you can say that he is never increasing. All right, guys, your turn. Hit next on the playlist. All right, last example for 1-1. It can be a lengthy one, so I may not completely finish it just because of how long it takes. Whew. Okay, average rate of change, okay? That's just another word for slope, which I really hope that you have heard slope before, because if not, we're in trouble. And you may remember that slope is m equals y2 minus y1 all over x2 minus x1. Okay? We're using that. So that means for slope, we have to have 2 points, right? 2 points. Okay, so here's how they made this Algebra 2 in an Algebra 2 question instead of an Algebra 1 question. They're quizzing you on your vocabulary. So notice this says interval from -2 to 0. That means that these are x values. Okay? So from -2 to 0, those are both x values in a point because it's on an interval. Okay? Now, what we have to do, I just realized my graph really isn't big enough for all of these problems, but that's okay. We have to figure out what are the y values. So there are 2 ways to do this. You can plug in, so what's the absolute value of -2 plus 2? Well, that's 4. Also notice that is where it is on the graph as well. They correspond with each other. If I plug in 0, absolute value of 0 is 0 plus 2 is 2. Hey, that's the same spot it is on the graph. Okay, now I have 2 points. So I can now do the slope formula for those 2 points. Okay, so I called these 2 and these 1, but it really doesn't matter. You should get the same answer. So 4 minus 2 and then negative 2 minus 0 is going to be 2 over negative 2, which is negative 1. That is a slope of negative 1. Well, another way I could have figured that out. It went down 2 over 2. Oh yeah, that is slope. Down 2 over 2 is negative 2 over 2, which is also negative 1. So don't be scared of slope. Slope can be easy. Okay? Let's keep looking here. 0 to 3. So the x values are 0 and 3. So at 0, y is 2. We already talked about that. At 3, I cut off the graph. If you're on Desmos, you can go look at the graph. Absolute value of 3 is 3 plus 2 is 5. All right, so 2 minus 5 over 0 minus 3 is negative 3 over negative 3. Use those math skills. Negative divided by negative is positive. So positive 1. Do you some division there? Notice this slope is different than this slope. What if I did the last one? So at negative 2, the y value is 4. And at 3, the y value is 5. Okay, let me back up for a second. So on this one, if I had had enough graph, I could have seen that I went over 3 and up 3. Right? But I kind of cut off the graph. Let's look here though. This one gets a little tricky because it was going downhill and then it starts going uphill. That's no fun. So what does that mean? Okay. Let's do 4 minus 5 over negative 2 minus 3. Is negative 1 over negative 5, which is positive 1/5. What the heck? They're all different. When we did slope in Algebra 1, it was always the same. But remember, you did slope when it was just a line. Notice this is 2 different lines connected. So all that it means when I get different slopes is that it is non-linear. It just means it's not a line. And hey, I knew that by looking at the graph. All the things. How cool. All right, you are now finished with 1-1. You will do the practice problem following this, and then you will complete your target in Canvas to be finished. Good job.